May 1, 2024, a day that marked a shocking event on our sun. At first glance, nothing seemed unusual, but out of the darkness, something incredible was stirring. On the eastern edge of the sun, a small, dark spot began to appear, barely noticeable to the naked eye. It seemed like any other sunspot, just another blemish on the fiery surface of our star. But this was no ordinary sunspot. It quickly began to grow faster than anyone could have predicted. In just a few days, it expanded to a size 17 times larger than Earth. Imagine that. A spot so vast, it could swallow our entire planet with room to spare. And it wasn't just growing, it was waking up. This colossal sunspot named Active Region 3664 started firing off intense solar flares and powerful coronal mass ejections. These are bursts of charged particles, some of the most violent phenomena in our solar system. They blasted out from the sun's surface, hurtling toward Earth at millions of miles per hour. As these bursts of energy surged toward our planet, something extraordinary began to unfold. A geomagnetic storm the likes of which we haven't seen in years was brewing. The energy from the CMEs smashed into Earth's magnetic field, creating chaos and beauty at the same time. The storm triggered one of the most breathtaking aurora displays in recorded history. For the first time, vibrant ribbons of light stretched across the skies of regions where auroras had never been seen before, far beyond the usual northern latitudes. These stunning light shows took over cities and landscapes, turning the night into a living canvas of glowing colors. It wasn't just a simple aurora, but what made this moment so special? Why did it happen now? And what does it mean for us? Stay with me as we dive into the science behind this sunspot event and what it tells us about our sun. The eruption of solar flares in May 2024 didn't just light up the skies with auroras. According to NASA, it triggered something far more intense, a geomagnetic storm so powerful it was the strongest in 500 years. This was no ordinary storm. It shook the very foundations of our planet's magnetic shield, causing deep underground observatories to tremble. Radio communications in certain regions were interrupted, making it harder for scientists, pilots, and even emergency services to connect. It's the kind of disruption that reminds us just how vulnerable our technological systems can be to the power of space weather. After the intense storm in May, the sun didn't let up. It kept firing off bursts of M-class solar flares, strong but not catastrophic, along with milder X-class flares. Space weather experts remained on high alert, wondering if the sun had more in store for us. With solar activity on the rise, questions loom. How long will this solar cycle last? Will the sun continue to send us more powerful bursts of energy? The stakes are high, and as we've seen, the effects can reach far beyond the skies. October 3, 2024 marked the date, because this was a moment that shook our understanding of the sun's power. On this day, the sun unleashed a massive 9.0 class solar flare. This was the most intense flare in 7 years, an explosive release of energy that came from the very center of the sun's disk. A flare of this magnitude doesn't happen every day. It was like a cosmic giant flexing its muscles. The shockwaves from this flare traveled across space at breakneck speed, and within just a week, Earth felt its wrath. What followed was nothing short of spectacular and disruptive. A G4 geomagnetic storm that painted the skies with vibrant auroras in places that rarely see them. From the farthest reaches of the northern latitudes to unusual spots closer to the equator, the storm lit up the night in a kaleidoscope of colors. But the beauty came at a cost. Radio communications were disrupted in parts of the world, causing confusion and challenges for communication systems. These dramatic events weren't isolated. They were clear signs that we were nearing the solar maximum, the peak of the sun's 11-year cycle, when solar activity is at its most intense. And this powerful flare? It was just one indication of what's to come. In a groundbreaking announcement, NASA confirmed a major shift in our sun's behavior. Its magnetic field had officially flipped. This event is more than just a scientific curiosity. It's a definitive signal that the sun has entered the solar maximum, the peak phase of its 11-year cycle. The magnetic field flip marks the point where solar activity reaches its highest intensity, sparking a flurry of solar flares, CMEs, and geomagnetic storms. We've already witnessed a taste of what's to come: increased solar activity that disrupts our technology, illuminates the night sky with auroras, and creates waves of energy that can affect everything from satellite systems to communications. The sun, our closest star, might seem like a constant, steady source of light and warmth, but the truth is far more dynamic. It goes through a series of dramatic transformations every 11 years. Unlike what we might think, the sun isn't a static ball of fire. Over the course of the solar cycle, its magnetic activity intensifies and wanes. Sunspots, dark, cool areas on the sun's surface, increase and decrease in number. The sun's magnetic poles flip, and solar flares and coronal mass ejections become more or less frequent. Today, thanks to advances in technology, we can monitor the sun's activity like never before. From the number of sunspots, to the magnetic fields swirling on the sun's surface, to the intensity of solar flares, we're tracking everything in real time. With tools like solar telescopes and space probes, scientists can observe the sun from space and analyze its behavior up close. These observations help predict solar storms, allowing us to better prepare for the potential impacts here on Earth. Understanding the solar cycle is more important than ever. The peak of the cycle, known as the solar maximum, brings with it more frequent and powerful solar events that can create auroras, disrupt satellites, and even affect power grids. By observing the sun's behavior, we can better understand what's coming next. When the sun hits its solar maximum, the effects on Earth can be spectacular, particularly when it comes to the auroras, the northern and southern lights. These dazzling displays become stronger, brighter, and interestingly more widespread. Auroras that were once only visible near the poles can now be seen at lower latitudes, lighting up the skies in places like the northern United States, parts of Europe, and even regions closer to the equator. But it's not all beautiful. The increase in solar activity also brings with it powerful geomagnetic storms. These storms can cause real disruptions on Earth, affecting everything from radio communications to GPS systems, and even power grids. The potential for chaos is real, and it's why experts are closely monitoring these solar events. The sun has officially entered the solar maximum phase of its 11-year cycle. This marks a time of increased solar activity, where solar flares, coronal mass ejections, and geomagnetic storms intensify, affecting not just space weather but life on Earth. While the solar maximum brings awe-inspiring phenomena like vibrant auroras, it also introduces challenges disrupting communications, GPS systems, and even power grids. Understanding the sun's cycles helps us prepare for what's to come, but it also reminds us that the future of our planet is in our hands. Stay informed, stay curious, and together, we can chart a path toward a sustainable future. If you enjoyed this exploration, don't forget to like, share, and subscribe for more fascinating insights into our universe. Until next time, keep looking up and stay curious.